triangle because we talked about congruent segments. Congruent segments are segments that have the same length. True. Thank you. Which in picture form, we could put a little dash on each line. Can you not see from there? Is it a bad angle?
No, it's not.
You sure?
Yeah.
Okay. You just were leaning really far over.
Yeah. That's all right. You want to switch? I've got it.
Oh, okay.
Yeah.
I'll just make sure you don't have to lay on the
No.
desk to see it. Okay.
I was trying to see around.
I gotcha. Fair enough. Fair enough. I do get in the way all the time. All right. We could write little dash marks here. Remember, you could use like 1 dash mark, 2 dash marks, 3 dash marks if you want to have different things. You could also, say there's 7 or whatever, but 2 ways to signify this. We could say something like AB is equal to CD. Or we could do the line above it, saying segment AB is congruent to segment CD. Oh, before I stop, on that purple sheet, I completely forgot about you guys. On the purple sheet, look at the dates. Look at that awkward switch from October to November. All of a sudden it's like 10 something and it's 11. Those should all be 10s. It's all October.
Wait, we have a test in 14 days?
Oh no.
That's 2 weeks from now.
That's okay. That's all the way 2 weeks from now.
Well, with most of them.
No, we won't. We actually pushed that test back just a little bit. We gave you an extra review day because it fell weird. It fell right before. We have, that's going to be the weekend where you have 4 days off. So it's a no homework weekend.
That's the day before.
Yeah. So it's either that or we have the day before that and you have a lesson and you have homework, which doesn't work out. So if you want to take it the day before, I'll give you that option if you really want to. I guess to get All right. Congruent angles we also talked about. Congruent angles, the symbol for an angle, congruent angles is just a little arc. Or you could have 2 arcs. Or you could have 3 arcs as long as the arcs match up between the 2 angles. In this case, we'd have the same measure. So if one is 45 degrees, then the other one must also be 45 degrees. In this case, we'd say something like angle X is congruent to angle Y. Or we could use the measure. We could say measure of angle X equals the measure of angle Y. Remember when you're talking about measures, that's when you put the equal sign. If you're talking about the angle as a whole, you're going to put the congruent sign. Emma.
So sometimes they have like a dash,
Yeah, I did have that on the review because that does show up. So sometimes they have little dash marks instead of. So let's say I have 2 angles. Sometimes I'd put 2 arcs on there, but other times you can just put little 2 tick marks on it, depending on the room and the style of stuff. Your goal when you're looking at these is just match up pictures. What do they have on one angle? Make sure it matches up with the other angle. There's other ways to do it too, and I'll just slowly introduce that stuff, but arcs are pretty much the primary one. All right, but we've already done these. We've already done congruent segments. We've already done congruent angles. But guess what makes up a triangle? Angles and segments, except now we have 3 segments and 3 angles that we have to put together. All right, so let's talk about triangles. 2 triangles are congruent if and only if their vertices can be matched up so that the corresponding parts, angles and sides of the triangle are congruent. In other words, can you finagle both triangles so they look the exact same? In this case, our top angles are the same. Our bottom left angles are the same. Am I missing something?
No, sorry.
Okay. Your bottom right angles are the same, and so are all your sides. So all this is really saying is, can you match it up so all the angles are congruent and all the sides are congruent? When you write a congruent statement for 2 polygons, specifically triangles, always list the corresponding vertices in the same order. In the same order. And let's break down what I mean by that. So let's first list our corresponding angles, list our corresponding sides, and then come up with the corresponding angle congruent statement. So our congruent angles are going to be something like angle A is congruent to angle D, as evident by the picture. We have 1 arc, one arc. Angle B is congruent to angle E based upon the picture because it has 3 arcs. They both have 3 arcs. And finally, angle C, not comma, but congruent to angle F. 3 congruent angles. We're halfway to having 2 congruent triangles. You need 3 congruent angles and 3 congruent sides. So let's list the sides that are congruent. So let's go in alphabetical order. We'll say AB, line AB is congruent to DE, it looks like, because they do have 2 tick marks on it. BC, segment BC must match up with EF because those both have 1 dash on them. And finally, we have, I guess, CA. Ka is congruent to FD. And you didn't have to put those in that order. You could say something like CA is congruent to DF. They're the same segment, it's just length. All right, now how to name these? I'm going to pick the first triangle's name. I'm going to call it triangle ABC. Remember, you can name it in any order you want to. Yeah, sorry.
I just wanted to know, well, I'm pretty sure it was, but you do have to have it in like the right spot. Like A can be, you can write like AB is congruent to ED.
Correct.
Can you or not?
Oh, could you write AB is congruent to ED?
Yeah, that's wrong.
That works.
It works.
It actually works because you're the same length basically, and you can switch the stuff. The only thing you can't do is you can't say like AB is congruent to EF or something. So in this case, you can flip letters if you want to. I usually put them in order because it makes it a little easier, but they don't have to be in order. So I could also do something like BA is congruent to DE. That works too because they're just lengths. The length doesn't change depending on how you order it. But that brings us to this one. Order is definitely going to matter here. Order is definitely going to matter when you're naming that second triangle. The first triangle, not so important. The second triangle is. Because I could name this first triangle ACB. I could name it BCA. Doesn't matter how I name the first triangle, but the second triangle has to match something. What has to match is all of the congruent angles must be in the exact same order they're laid out here. So this is triangle ABC. When I name my other triangle, it must be the angle that's congruent to A, the angle that's congruent to B, followed by the congruent angle to C. So in this case, A is congruent to D, so this is going to be triangle D. B is congruent to E, so we're going to put E here. And finally, C is congruent to F, so we're going to put an F here. After you name your first triangle, your second one has to follow suit. The congruent angles must match up. But as I said, you could have picked a different first triangle name. We could have named it, let's call it CBA. That way you got BA in there, right? Does someone take a shot at what I'd write for that second triangle? First triangle doesn't matter. It's the second triangle that really does. Yeah. Did you say FED? Did you say FED?
Yeah.
Okay, I don't know. Let's check it. So C and F must be congruent. They are. B and E must be congruent. They are, which generally means that last one has to be congruent as well. Libby?
So does the B always have to be in the middle?
Nope.
No.
Nope. Because you could do triangle BCA or BAC as long as your second triangle matches suit.
Oh, alright.
Okay? So there's many other options. Like I said, we could start with triangle BCA. In that case, it'd be congruent to EFD. Just make sure your second triangle matches suit. Naming a triangle, you just pick any 3 letters in any order you want to.
So you can't do like A, C, B, and then E, D, F?
Be careful. You said A. Did you say ACB?
Yeah, and then you can't do E, D, F. Or-
You can't do EDF, correct. You'd have to do DFE. E. It has to match that exact same order that you picked.
Yep, alright.
So you picked A, C, B, right? So it has to be, the A came first here, so the D has to come first here.
Okay.
Your C came next, so the F would have to come next. And finally, you picked B for your last one, and so E has to be your last one. All right, just make sure your congruent angles match up.
Alright.
First triangle doesn't matter, pick anything. Second triangle is the one that really matters. And we'll have lots of practice doing this. All right, real quick, we're supposed to write a congruent statement for the following triangle. Can someone name the first triangle, so the one on the left? Just pick a name for that triangle, and I don't mean Bob or something. Pick one that actually makes sense with it. Yeah. JKL. All right, JKL. That was the first triangle. Someone name the second triangle based upon JKL. Sangha? Say that one more time. RST. Let's double check. That means J and R must be congruent. Let's check it. J and R. TSR? Okay. Like I said, now's the time to make mistakes, right? Save those now. So you said, what's your triangle? TSR. Let's check that. All right, that means J and T must be congruent. Let's check it. J and T, they're congruent. K and S must be congruent. K and S are congruent. And finally, L and R are also congruent. Can someone name that first triangle a different way? Yeah. LJK. Can someone name the triangle that's congruent to LJK? RST. What was that? Did you say RTS? What did you say? No, I'm going off what he said.
Oh, RST.
RST. Let's check it. All right, that means L and R must be congruent. L and R are congruent. It means J and S must be congruent. Are J and S congruent?
Oh.
What should it be?
RTS.
RTS, perfect. Does that make sense though? I had to flip those two? Yep, nope, no problem. Here's the time to make your mistakes. Make them all during class, and then you can't make any mistakes on the test because you ran out of them. All right, this one, we're going to shorten this problem just a little bit. We're just going to find x. I'm sorry, we're not going to, yeah, we're just going to find y. I lied. We're just going to find y. We're going to shorten this problem because it basically just talked about angles. So we're just going to find y. And that's based upon just the name. If they just give you this name, you can actually help you find y. So if they give you ABC is congruent to DFE, we're going to pull some facts out of there. We know that angle A is congruent to angle D. We know angle B is congruent to angle F. And finally, we know angle C is congruent to angle E. Well, that's really important information because, and here's a little trick for you guys. When you guys get information, write it on your drawings. Write that information on the drawings. It's going to save you time later. I can't tell you how many people struggle with homework because they just don't write on their pictures, where they're like, I forgot what happened here. We have lots of stuff happening. Just write that information down, like angle A is congruent to angle D. So what I would do on A and D is I'd put a little mark saying, hey, those are congruent. So later on I can check it. B is congruent to F. Put a little mark on B and F, so maybe 2 marks on B and F. And finally, C and D are congruent, so I'll put a triple. 1, 2, 3. I'll put a triple on here. Now, this one isn't a long problem, but you'll have long problems. And the more information you have, draw it on the picture. So in this case, I'm looking at, well, this says AY minus 5 equals this angle, and this angle equals 99. Well, just for my drawing, I know that those two things are congruent, so 99 has to equal 8y minus 5. So just from that information, that B is equal to F, we're going to know that 99 is going to equal that 8y minus 5. I'd add 5 to both sides. We have 104 equals 8y. Can someone tell me what y equals based upon that? Alex?
13.
Y equals 13. All right, I just shortened that problem because we don't need to do the other one. It's the same style. I'm about to switch to a slide. That is probably one of the most important, if not the most important, part of this whole lesson that you're going to use over and over and over and over and over again. It is CPCTC. You need to know this. You need to know CPCTC. CPCTC says if two polygons are congruent, then corresponding parts are congruent. For triangles, we're going to say the phrase corresponding parts of congruent triangles are congruent. You can use CPCTC to solve for missing variables involving congruent parts. That should say parts. I don't know why it says pars. Or as a reason in a proof. What CPCTC lets you do, as soon as you say two triangles are congruent, you can now say like angle A is congruent to angle D. You can say angle F is congruent to angle B, or however order you have it in. This allows you to say this. This is going to be your reason once you know two triangles are congruent. So remember, CPCTC. Or you can, and it rolls off the tongue, you could say it this way. You can say kapukatika. Kapukatika. It rolls right off the tongue, doesn't it? Or you can just say CPCTC. Kapukatika. Kapukatika. It's kind of fun to say, though. All it means, once again, how important this is, once you prove that two triangles are congruent, or you're shown two triangles are congruent, all of the parts are also congruent. All right, information from naming congruent triangles. What we know with just the name. If I say triangle ABC is congruent to triangle GLM, we know a whole bunch of information. We know that angle A is congruent to angle G. We know that angle B is congruent to angle L. And finally, we know that angle C is congruent to angle M. We know even more information. A triangle has 3 congruent angles, and it also has 3 congruent sides.
Yeah.
It has 3 congruent angles and 3 congruent sides. We actually know the congruent sides by the name, just the name. I now know that AB is going to be congruent to GL because they're listed in the same place in the same order. AB is congruent to GL. I also know that BC is going to be congruent to, anyone want to guess? LM. And our last one's going to be CA is congruent to which segment? Just shout it out. MG. So if I just name triangles, yes, you can draw them. Yes, you can do all that kind of stuff. But sometimes it's just easier, especially if I have a test question that says, hey, triangle ABC is congruent to angle GLM. Angle A equals 30 degrees. What is angle G? And you go, 30 degrees. Wait, isn't having to draw a whole bunch of triangles and draw a whole bunch of congruent stuff. Just know that naming is important with triangles. All right, things, triangle is a polygon. So the same thing works for all polygons. Polygons are congruent if and only if their vertices can be matched up so that their corresponding parts are congruent. Why that helps us is we have break and choke. I named it that way because angle B must be congruent to angle C. Angle R must be congruent to angle H. And finally, angle A must be congruent to angle O. I don't feel like listing all of them, so I'm just going to go ... from there. Yes?
What happens when we get to K? Just K equals K?
K equals K. E equals E. Yep. But same thing with triangles. Our segments are also congruent based upon these statements. So BR must be congruent to CH. RA must be congruent to HO. And so on and so forth. As long as those two letters are in order here, and they're in order here, they make sense. I'm going to add one more thing to this drawing because this is an important kind of thing. See this EK? That is oftentimes referred to as a common side. And it must be congruent because they're sharing it. It's a common side. We're going to use that a lot with triangles. When two triangles are butted up against each other, you can say, well, that side must be the same as that side because it's the same thing. All right, the next thing we're going to do is we're going to do a couple graphs, and then we're going to be done, and the rest of the time will be for yours to work. So in these graphs, the very first thing I'm supposed to do is I'm supposed to name the coordinates of points A, B, and C. This is just practice writing coordinates. Remember, your x value comes first. Your y value comes second. So if I have to name A, B, and C, A is going to be the point, well, it goes 1 over on the x, up 2 on the y. So our A is going to be 1, 2. The B value is going to be over 4 on the x-axis, up 2, so it's going to be the point 4, 2. And finally, our C value is going to be over 2, up 4, so it's going to be 2, 4. All right, the very first thing we need to do is we need to pick a point D so that ABC is congruent to triangle ABD. So that means we're using AB. We're not using this EF. We're not using this EF. Yeah?
2,
2, 0. Let's check that out. So he's saying 2, 0 is going to be the triangle we're talking about. So I'll draw the triangle, and then we'll make sure that it is correct. So here's the triangle that EJ wanted to create. And this is going to be my D. All right, let's see if it's right. So we're making sure ABC is congruent to ABD. So first of all, is AB congruent to AB on this one? Yeah, it's a common side. So let's mark that. What color could I pick that stands out? Maybe green? So those match up. Our next ones that have to match up are BC has to be the same length as BD. Well, BC is up to over 2, and BD is down to over 2. Is that the same length? Yeah. And let's just check the last one. It should be that CA, which is up to over 1, should be the same thing as DA, which is down to over 1. That is the same length as well. We have a correct answer where we have D is going to be the point 2, 0. All right, let's do one more together, and then you'll do one on your own. Our next one says we have ABC. We're supposed to make that congruent to EFG. Well, so our AB must be congruent to EF. That's already taken care of for us. It is the same length. AB is 3 units, EF is 3 units. Now I need a G value. I need a G value that's going to be the same thing as, so BC has to equal FG. Well, BC is up to over 2, so let's just go up to over 2 and make our G value. G isn't that great. And let's connect that. Well, that's because BC is up to over 2. That matches. Now, the last thing I have to check is CA the same thing as GE? Well, CA would be left down. This one's left 1, down 1. So yeah, that's the same exact length. So my G value is going to be 6, 5.
do like 6-1?
Could you? Let's check. Could we do 6-1? Would 6-1 also work? Let's do that in blue. So 6-1. So she's saying that this triangle will also work. Let's color it in and see if it works. All right, we already know that AB equals 3. EF works. Well, now we have to say BC equals FG. BC is up 2 over 2. FG on this one is down 2 over 2, so that works. That matches that. Finally, our CA is up 2 over 1. In this case, it's down 2 over 1, but it's still the same length. So G has 2 possibilities. It could be 6-5, or G can be 6-1. Try the next one if you haven't already. Try the next one if you haven't already. I don't want the answer for it yet. Or did you have a question, Sana? No, you're giving me an answer? Okay. You can give me the answer when we get to it. I'm going to give everyone a slightly a different way. So he's saying, I'm sorry, not F, H. That should have been H, right? That should have been my H value. All right, notice this says A to B to C. So we're going A, going in this direction, A to B, and then B to C. Well, in this one it says F, E to H. So I would kind of drag my pencil and go, okay, I'm going F to E, and then I need something that goes up to H. Well, in this case, if I go A to B, going from B to C is up 2 over 2. So when I'm going from E to H, I should go up 2 over 2 as well. So I'm looking at that point right here. Is that the 0.75? Yep. And then to get back down from C, you go over 1, down 1. So in this case, you go over 1, down 1, which brings you back to F. So that is, in fact, our point. Yeah, Krupa.
Oh, wait, no.
You sure? Okay. So this is my H. You positive? Because you want F to E, E to H, which needs to be up 2 over 2, and then to get from H to F, I need to go over 1, down 1, which all works out. And then just to double check, I have too much stuff on here. Let me redraw this. To double check this point, we could check lengths. A to B is the same thing as E to F. E to H is the same length as B to C, and finally H to F is the same length as C to A. Yeah.
And then there's the other one.
And there's one more. What's the other one?
7-1, right?
7-1. Let's check it. So we're saying and 7-1 will work. So let's plot 7-1. 7-1 would be right here. Let's draw the triangle. Our AB has to match up with FE, which it does. Our BC has to be the same length as our EH, which is the same length. And finally, that CA has to match our new HF, which it does. So yes, the 0.71 also works. All right, questions on either one of those two graphs? You have to do some of that in the homework as well. All right, guys, real quick, look at your homework. Look at your homework. There's a couple things I want to go over. First of all, look at problem number 10. Look at problem number 10A. Problem number 10A. That should say STO, not STU. There isn't a U on there. It should say STO, not STU. The second thing I want to bring up, pay attention to this. You'll see a bunch of becauses in there. A lot of times your because is CPCTC. So anytime they give you two congruent triangles, and you say that two parts are congruent, your reason is CPCTC. I'm not saying all of those because because it's our CPCTC, but a bunch of them are. Just ask yourself, do you know this because they gave you two congruent triangles? If that is why, then you're going to use CPCTC. All right. Otherwise, the rest of the time is yours to work.